Welcome to BSR Studies. I am Bala. Yesterday we have discussed linear momentum and Newton's third law. In this video, I will explain about weight. So, we already learned about force. Force means the product of mass and acceleration. This formula we have to use when a body goes in a straight line. When a body goes in a straight line. So, the weight formula is weight is equals to mass into gravity. Here weight formula is mass into gravity. Here gravity means I am taking this is an object. This is an object. If I leave from a certain height, the gravity pulls down the object. Here gravity pulls this object. This is the meaning of gravity. So here gravity value is 9.8 meter per second square. The approximate value is 10 meter per second square. We can use this and this also. Okay. So here weight means mass into gravity. So here this formula we have to use in freely falling bodies. Freely falling bodies. If I leave from certain height, this is also a freely falling body. Okay. So this is the weight formula. Weight means the product of mass and gravity, and this formula we have to use in freely falling bodies. Okay. So next topic. Newton's third law. Newton's third law. We already discussed about Newton's third law, which means every action has an equal and opposite reaction. Every action has an equal and opposite reaction. Every action has a reaction and equal and opposite. If I punch this board, I will get pain and it goes some distance. So it goes some distance means I am acting on this board and I will get pain. So that is reaction. Action is equals to minus of reaction. Action is equals to minus of reaction. Here action and reaction are equal in magnitude. Important point. Action and reaction are equal in magnitude. So here if I take reaction to this side, action plus reaction is equals to 0. This is very important. If I punch this board, some force will apply and goes some distance and I will get pain. So reaction and action we can add, it becomes 0. When action and reaction both get added, it will become 0. This is very important point. Action and reaction, when these get added, it will become 0. Okay. So in this, action and reaction are two forces. Action and reaction are two forces which applies on two different bodies. Action and reaction are two forces which applies on two different bodies. If I punch this blackboard, this is one of the body and hand is one of the body, for example. So action and reaction are two forces which applies on two different bodies. Okay, not single body, two different bodies. Okay. So this is the Newton's third law. What is Newton's third law? Newton's third law defines that every action has an equal and opposite reaction. Okay? If we see examples, man walking on the road. Man walking on the road. I am walking in this road. I am applying some force on the ground to walk some distance. I am acting on the road and it shows some reaction, pain. That pain is reaction. Okay? So, man swimming, and third one, horse pulls and cart. Horse pulls a cart. Okay, so these are the examples. So this is the Newton's third law. And next topic, types of forces. Types of forces. In this there are four forces. Four types of forces. Four types of forces. In that, first one, contact force. Contact force. Contact force means force should be applied when two bodies are in contact, direct contact. Force is applied. Force is applied when two bodies are in direct contact or string or rope. Contact force is applied when two bodies are in direct contact or tied in with string or rope. So if I am taking this is one of the body and tied with rope, this is another body. This body goes some distance through this side and the body gets displaced on this side also. So it applies some force to displace some distance. It also force applies some distance to displace. So this is the direct contact applying two bodies. Okay, if I apply 5 newtons on this body also gets 5 newtons and displaces. Okay, so this is the contact force. So in contact force there are 8 types. In contact force there are 8 types. In that, first one, muscular force. Muscular force means the force done by our muscles. The force which is done by muscles. So next type, mechanical force. This force is applied when any car is turned to any direction. The car tire is connected to one of the part of the car. So that mechanical system is called mechanical force. Some force is applied to handle to get in another direction. That is mechanical force. Okay. Third type, spring force. Spring force. Spring force means I am taking this is a spring and it is connected to one of the body. When spring is compressed, it displaces some distance. When spring is elongated, it displaces and some other distance. So here the formula of spring force is force of spring. Force of spring is equals to minus kx. Here x means displacement. Here minus is because it compressed. When it compresses, it displaces some distance to this side. When it is elongated, it displaces some distance through this side. So the formula is force of spring is equals to minus of kx. Okay. Normal force. Normal force means I am taking this is a surface and this is an object. When normal force is applied means if body is perpendicular to surface, this force is called normal force. When body is perpendicular to surface, that force is called normal force. Tensional force. Tensional force. I am taking this is a rigid support and it is tied to a body. Here this is a tensional force because this string pulls to rigid support. That is called tensional force. This is represented as P. Okay. So these are the main types of contact forces. So next type of types of forces. Next type, non-contact force. Non-contact force, the force which is applied in any other distances. Suppose I am taking this is one of the body and this is one of the body. The force is applied from this body to this body, which is not direct contact and tied with string or rope. this is some distance from this body and this body, 2 kilometers, and force is applied from this body to this body. This is called non-contact force. Okay? When body is not in contact and tied with string or rope, that is called non-contact force. And third types of forces. Balanced force. Balanced force. Balanced force means I am taking this is a normal surface and this is an object. I am applying some force on this direction 2 newtons and applying some force on this direction 2 newtons. The body is equilibrium, means it stays on this state only. It stays in this rest position because 2 newtons applied, 2 newtons applied. So this is balanced. Equal newtons is applied, so this is balanced. Balanced because 2 minus 2, 0. If both forces are in both directions are in opposite, we have to subtract. I am taking this is an object. I am applying some force 2 newtons on this direction and on this direction I am applying 2 newtons. Both forces are in same direction, so we have to apply, add 2 plus 2, 4 newtons. If both forces are in this direction, same direction, so we have to add. Both forces are in opposite direction, we have to subtract. Okay? So both forces are in opposite direction, so we have to subtract 2 minus 2, 0. So it is in rest state. Okay? This is the third type, balanced force. Fourth type. Unbalanced force. Unbalanced force. I am taking this is a surface and it is an object M. I am applying some force on this direction 2 newtons and in this direction also 2 newtons. Here force applied is 2 plus 2 because these forces are in same direction. So 2 plus 2, 4 newtons. So this is unbalanced. Balanced means it is in rest state when 2 forces are applied. Unbalanced means 2 forces applied, it displaces some distance. Okay? I am taking on opposite direction 4 newtons. Opposite direction 4 newtons. So here we have to subtract 4 minus 2, 2. 2 means it displaces some distance through this side. So it is also an unbalanced force. Okay? These are the types of forces. So today topic is completed. మీకు నచ్చితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి.